we design for reliability. And these are some of the things we learned in the aerospace industry, the spacecraft industry. As a matter of fact, later, when we're done here, I'll walk you into the next room, you hear that machine running in the back. We actually thermal cycle your amplifiers, okay? So each amplifier, it's a military program called Mil Standard 810. It's designed to stress components to develop the reliability, so you can engineer for reliability. So what's in that chamber right now is the engineering model for the 34S1, the ADL-34 is in it, and it's soaking at minus 30 C while it's operating.
Oh, wow.
So, and just so you know, Mil Standard 810 is 10 cycles from minus 30 C to plus 50 C with an hour soak at each end, each temperature range.
Goes on and off too, so that's cryogenic.
The amplifier's running the whole time.
Oh,
Vacuum testing.
No.
How quickly?
It's a good idea though.
How quickly will it go from minus 30 to plus 50?
It's actually ramps very quickly. I can show you, I actually have charts I can show you. It goes very quickly. If I had to guess, probably 15 minutes. And it's designed to stress the hell out of the components. If something's going to fail, it's going to fail in this test condition. But the other thing that makes our amplifiers unique and ultra reliable, and Rob mentioned that we restore amateur or communications radios. And right around the time of the Vietnam War, I've restored pre-war radios where they use either PVC wire or some even cloth-covered wire. When you open the radio in the pre-war, you've got to replace a lot of the wiring because the wiring dries out. You know, radios, electronics, they get hot, especially tube electronics, analog electronics, and it ages the wire. The wire crumbles and dries out. So it affects the overall reliability of the radio. Around the time of the Vietnam War, they went to Teflon wire. And actually, the military never went away from Teflon wire. They wired the Aegis cruisers with Teflon wire. And I've opened radios from the Vietnam era. They hadn't been opened since they've been in the field. And they look like the day they came out of the factory. And I'm going to pass this around. These are some samples, and you can feel it right away, the difference in what the wire is like. All the small signal information in our amplifiers gets run in coax. So one piece I pass around is going to be a Teflon coax. And this is just Teflon. It's an 18 gauge wire. It is silver plated copper. It's about $600 a roll. Okay, but I guarantee you that your kids are going to fight over the amplifier when you're gone. But I want to show you something. This is a heat gun, which everyone's seen. It gets very hot.
Yeah.
And it's designed, huh?
Teflon doesn't know.
It's designed, you know, for heat shrink tubing. It gets very hot. It's not like a hair dryer.
Right.
And you'll see now, if we did this with PVC, I don't have a piece of PVC wire. We don't keep it in the shop here. But I can stand here all day with the thing, and there's no change to the wire whatsoever. I mean,
They make oven mitts out of Teflon. They make oven mitts.
Yeah. Well, they make cookware with Teflon. Teflon ain't probably poisoning us, but it is a unique material. Now, I got to tell you, any plastic-based wire would have been long gone with these temperatures.
And you can light a cigarette off that thing.
It's very hot. It's very hot. So it's, as you can see, it hasn't changed the wire at all. The wire's just like it came off the roll. So you can pass these around. You can take a look. You'll feel the difference immediately. If you felt hookup wire in the past, you'll feel the difference immediately in that wire. But it's expensive. And that's kind of what drives our products. I mean, look, this is a niche business, and I like to say it's not a consumer electronics business. My partner would argue with me, but it's not a consumer electronics business. We build equipment that is consumed by very few people. We have the ability to build them by hand. We use all the best materials we can find. All our capacitors are all U.S. made. All the components, with the exception of the tubes and the binding posts. Tubes coming from Russia, the binding posts coming from Japan. Are all American-based mil-spec resistors, 1% resistors. They're the best components that money can buy, but it does drive the cost. So
Whose resistors you use?
various, we get them from various suppliers. Vichy is probably our biggest one, but they're epoxy. I'll show you some resistors. They're dipped in epoxy. I can do the same thing with the heat gun on the resistor. Right.